Hello everyone, I'm Ishita from Fun to Learn, and today we will be talking about atoms and molecules. And then a little later on, we'll start talking about the chemical bonds. So first things first, we need to know what atoms are. We know that matter is anything that has mass and occupies space. So basically everything around us is matter. Okay? Everything around us is matter, but the sound, the vibrations that come out of our phone, the sound waves that are coming out of my mouth, these are not matter because we cannot touch them. They do not occupy space and they are not made up of mass. However, air has mass, which is a whole different topic which we will learn in another video. Now, that mass that we were talking about is made up of these small particles, which we call atoms. And atoms are the smallest particle of a chemical element that can exist, the smallest particle. And let's dig a little deeper into what atoms are, because I'm curious and I'm pretty sure you are too. So this structure that we have in front of us is the structure of an oxygen element. The O, which is the symbol of oxygen, represents oxygen. So we know that this structure is made it belongs to oxygen. So this circular thing here, or this sun-like thing here, is actually called the nucleus. And we have protons and neutrons present inside the nucleus, and they carry the charges, like the positive charge, which is carried by the protons, and negative charge, which is carried by the neutrons. And then we have these orbit-looking like things, which are present outside of the nucleus. And these orbit-looking like things are what we call shells. And they're not like the shells that we find at the beach. It's just that we call them shells. And these planet-looking like structures are actually called electrons. A fun fact here, the atomic number of any element is equal to the number of protons or electrons present inside the atom of the element. So oxygen's atomic number is 8. Hence, we have 8 electrons. We count them all together. In the first orbit, we have 2 electrons. And in the second orbit, or the second shell, we have 6 electrons. Now you might be asking, why don't we have all 8 electrons in one shell? Why do we need to split them up into shell 2, shell 3, shell 4, etc.? Because each shell can only occupy a certain number of electrons, and to determine the maximum number that it can occupy, we use the formula 2n squared. Okay, where this variable n, represents the number of the shell. So if we have the first shell, we apply the formula 2n squared, which will be common for all the shells. We apply the formula 2n squared, and then we solve it. We have the 2 in the brackets. We replace n with 1 because it's the first shell, and 2 times 1 squared, which is 2. So hence, we can only have 2 electrons in the first shell as we have here, and then we have the answers over here, 2, 8, 18, 32 for the certain shell. Usually a shell, an atom does not exceed the third shell, but in some cases, in rare cases, it does. But no element or no atom exceeds the fourth shell. Now that we know about atoms, let's talk about molecules. Molecules are bonded atoms. So basically, when one atom bonds with another atom, it creates a molecule. So the definition of a molecule would be a group of atoms bonded together representing the smallest fundamental unit of a chemical compound that can take part in a chemical reaction. We have wrote the smallest fundamental unit because when we do chemical reactions, when we mix one chemical solution with another, the molecules are the ones that react, not the atoms. Hence, we use the word fundamental because if we have only the smallest unit, that would be atoms. The atoms are the smallest units, but the molecules are the smallest fundamental unit. So now let's think about our childhood. In our childhood, many times we have used or heard the word H2O, but we never thought about what it means. Some of us, instead of saying water, use the words H2O to outsmart others or to show others how smart we are. And I'm pretty sure we got compliments for that. But did we ever think about why we use the word H2O? Or why H2O means water? If we look at H2O, this is actually the chemical formula for water. Yes, that's right. It is the chemical formula for the water molecule. We have H2. H stands for hydrogen, as we all know. 2, the subscript 2, represents the number of atoms required by that element. So here we have 2 atoms of hydrogen, and there's nothing written underneath 0, which means there's only 1 atom of oxygen. I'm sorry, this is not a 0, it's an O. So H2O, we have 2 hydrogens and 1 oxygen. As we can see here, 2 hydrogen atoms and 1 oxygen atom. Now, why do atoms bond with each other? Why do they? What's the need? Can't they live their own world peacefully? Well, the thing is that in the periodic tables, we have halogens, we have the noble gases, the rare earth metals, etc., etc., etc. Let's connect this periodic table of elements world with our real world. We have our presidents, our leaders, our comedians, our great TV actors, our prime ministers. We all love them and they inspire us, don't they? Same way, we want to be like them. In the same way, the noble gases are the celebrities, they are the leaders, they are the people who inspire the other elements. They're not exactly people, but let's count them as people. They deserve it. So all the other elements want to be like the noble gases. What's so important in being the noble gases and why are they famous? Because the noble gases are stable in nature. They do not bond with anything. And to be like the noble gases, other elements bond. For example, helium is a noble gas with an atomic number 2. Hydrogen wants to be like helium. One more thing here. The element only tries to attain the properties of its nearest noble gas, not only any noble gas, its nearest noble gas. If somebody's 32 years old and there is a leader of 32 years old and 65 years old, obviously the person would choose to follow the path of the great leader who is 32 years old. In the same way, all the atoms choose to follow the path of their nearest noble gas. So in order to have 2 electrons, hydrogen needs to bond with someone. And in order for oxygen to become like neon, which is again a noble gas, oxygen is in need of 2 atoms. Electrons, 2 electrons. So here we have 1 hydrogen. This X, what does this X mean? Here's one atom which belongs to hydrogen, another atom which belongs to hydrogen. Then on the outer shell, as we learned before, we have 6 electrons in the outer shell of oxygen. 1, 2, 3, 4, and then these 2 X's, 5 and 6. What are these X's doing? They are sharing their electrons with hydrogen, because hydrogen needs 2 electrons, and even oxygen needs 2 electrons. So there's one hydrogen. Oxygen is sharing, it gains an electron, right? This is a share between oxygen and hydrogen. This is the share between oxygen and hydrogen. Here, yay, we scored. We got 9 electrons. Let's take another hydrogen here. A share between hydrogen and oxygen. Another share between hydrogen and oxygen. And we reached 10 electrons for oxygen and 2 electrons for hydrogen. So it's a win-win situation where the hydrogen and oxygen bonded and they didn't become noble gases. They became like noble gases. So what are the types of bonding? We have 2 types of bonding. We have covalent bonds and ionic bonds. Let's learn a little more about them, shall we? We have covalent bonds. Covalent bonds are the result of the sharing of 2 electrons between 2 atoms to form a molecule. These covalent bonds actually share the electrons, right? And a famous example, which we were recently talking about, yay, our favorite water. We have water here. As I said, the oxygen and hydrogen share. The oxygen and hydrogen share. And sharing is good manners. So sharing is basically a covalent bond. Now let's get on to ionic bonds. What are ionic bonds? Ionic bonds are the transfer of electrons to other atoms and electrostatic forces that hold the atoms together. What does this mean? I didn't understand, right? Now let's learn this with the help of an example. Which example you say? Something that we cannot live without, and something that brings taste to our food. If you guess salt, yep, that's right. We have NaCl here. So NaCl, in order to become an noble gas, had one extra electron. The yellow represents NaCl. And Cl, which is chlorine, this is sodium, and this is chlorine. So chlorine, in order to become a noble gas, was in a deficit of 1 electron, which means it needed one more electron to become a noble gas. So what happened here? 1 and 2 became friends. 1 and 2 became friends. 1 and 2 became friends. 1 and 2 became friends, and 1 and 2 became friends. But this extra atom was left alone. It had nowhere to go. And sodium didn't want it because it wouldn't be able to become a noble gas then. So it transferred or gave away its electron to chlorine. That way, chlorine was able to become a noble gas, and so was sodium. So ionic bonds are the transfer of electrons, as we saw, the transfer of electrons to other atoms and electrostatic forces that hold the atom together. So there's a force called electrostatic force, which we will learn later, probably in physics, and that force is what holds these 2 atoms together. Now let's have a little recap on what we have learned today. Today we have learned about atoms, molecules, and we have recently understood our chemical bondings, and I'm pretty sure you all understood it. So we know that matter is composed of tiny particles called atoms. And atoms are the smallest part of an element. That is still that element. So when an atom is formed in that element, it's not separate. It's still part of that element. And a molecule is two or more atoms joined and acting as a unit. So when two or more atoms join and become a whole, they act as a unit. They become a whole. And that whole is what we call a molecule. Just like this, we learned it. We have an oxygen atom and hydrogen atom. We added one oxygen atom, two hydrogen atoms, and it became a molecule. So two or more than two atoms join and are acting as a unit. So thank you for listening to today's video. I hope you learned a lot. And if you have any questions or something that you want to ask about, any topic that you want me to teach about, I'm going to leave an email ID in the description box below. And you can send any of your questions, any of your topics that you want to learn, any challenges, or anything you want us to do. And please subscribe, like, and share this video as much as you can so everybody can get the opportunity of learning about atoms and molecules. Once again, goodbye.